So the first video was for numbers 1 through 35, which is part A. Part B deals with a separate section of these standards. Part A is standard 4, dealing with science, and then part B is standards 1, 2, 6, and 7, I believe, which is more math skills and like applied math skills, things like graphs and stuff like that, estimation, whatever. So let's proceed. And they often open up part B with one of these estimation questions, which says which measurement is closest to 1 times 10 to the negative 2 meters? Diameter of an atom, width of a finger, length of a football field, or height of a school teacher. And then it's like, man, I don't know what those things are. I don't know how wide my finger is. I mean, you have a ruler, you can measure it. But the height of a teacher, diameter of an atom, but these are estimates, right? So ballpark questions. So first, 1 times 10 to the negative 2 meters. What even is that? So we have 1 times 10 to the negative 2. That's 10 to the negative 3. Whoops. Let's try that again. 1 times 10 to the negative 1, 2. That's 0.01 meters, aka a centimeter. So when you sit for the exam, you'll have a centimeter ruler. And so, like, in terms of like the size of a centimeter, at the scale of this video, I just pulled out a ruler and I just marked 1 centimeter. Now, as I scale the video, that changes what a centimeter is. But again, what's close? Like, for instance, that by no means is that a football field or the height of a person. So definitely not. And then, like, diameter of an atom, like, we can't even see an atom. Forget about that. Like, you can actually see this centimeter. And so your finger is roughly the width of a centimeter. Is it exactly a centimeter? No, it's probably a little bit bigger. But width of a finger, closest thing. So, like I said, there could be, like, estimation is a skill that you bring to physics, not necessarily science knowledge. Anyway, so 37, now we're looking at different graphs, and it says relationship between speed and time for something freely falling object. So we know for something freely falling, the acceleration is constant at about negative 9.81 or negative 10 meters per second squared. Acceleration, of course, is how speed changes with time. And so if the acceleration is constant, that means that the rate by which the speed changes is constant, so the speed will increase at a constant rate. But if the speed is increasing, that means that the displacement, the actual distance that the object falls, is just an object, that the object falls, that distance is going to get greater and greater and greater. That displacement is proportional to time squared. And so if the speed increases at a steady rate, the answer to number 37 is 4. But we can actually, if it would be choice 3 if instead of speed, this were displacement. Or it could be choice 1 if instead of speed, it was acceleration, magnitude of acceleration. But it's not those things, it's speed. It's definitely not choice 2, but choice 2, this graph for choice 2 does show an inverse proportion. As something goes up, something else goes down. Resistance and current are inversely proportional. That's a good example of that. Or frequency and wavelength are inversely proportional. But that is not the case for number 37. We're talking about speed versus time. For a freely falling object, it is choice 4. Moving on. Okay, here we are with number 38. Let's write down our given information. We're going to solve for the energy. So 38 gives the resistance and the voltage and the time in minutes. We're going to need to put that in seconds. And it's asking for the energy, the electrical energy, which we know that when we're talking electricity, instead of solving for energy, we solve for work because work is energy. And so 2.5 minutes, each minute is 60 seconds, so 2.5 minutes, that winds up being 150 seconds. And so if we're going to solve for the energy, again, the electrical energy equations, we're solving for work. So when I say energy, energy is work, so we're going to be solving for the work. And so we do have an equation that work or energy is voltage squared times time over resistance. That's on page 4 of the reference table. Don't forget to square that voltage. And when you solve for the energy, you get 225,000 joules, which would be 2.3 times 10 to the 5 joules. It's two significant figures because the time and the resistance are given to two significant figures. Now we have 39, we have the weight of 46 newtons. Let's write that down. Weight is 46 newtons, and it is at rest, and it's on an incline of 25 degrees with the horizontal. And there's the bell. The question asks for the component of the box weight perpendicular to the incline. And so this incline or ramp, we have our ramp equations. We have F parallel along the ramp is weight sine theta, but F perpendicular is weight cosine theta. And remember, we need to be in degree mode, so we get 46 cosine 25, and we wind up with 42 newtons. That is choice 3. Okay, so we have position versus time graph, D versus T graph. Things that I know about a D versus T graph: slope is velocity, right? So then it says traveling with a positive velocity, so the velocity is positive, so that means that the slope is positive. So definitely not choice 1, and not choice 4, and not choice 3. So it must be choice 2. Oh, wait a minute. Number 1 does have a positive slope. What am I talking about? All right, so it's either choice 1 or it's choice 2. Choices 3 and 4 have negative slopes. But then it says, and a negative acceleration. Well, we know that acceleration is a change in velocity. And if the velocity is the slope and the object is accelerating, then there will be a change in the slope. And then choice 1 has a constant slope. That is a straight line. Not a constant position, but a constant slope. So it's not choice 1, it is choice 2. And then we can get a little bit deeper into that. It says positive velocity and negative acceleration. So then the acceleration is acting against the velocity, so it should be slowing down. So the slope is positive, but getting more shallow. So yes, in fact, it is slowing down, and there's your negative acceleration. But you didn't really need to know that level in order to answer the question. Just know that acceleration is changing velocity. Velocity is slope of position versus time. So if there is an acceleration, the slope will change, hence a curve. And it's not the choice 4 curve, because choice 4 has a negative slope. Okay, number 41. We have two cars and traveling at a constant speed, and it says that A is going it's initially 200 meters behind B, and it's going 20 meters per second. And B, hold on. Car A moving in a straight line at a constant speed of 20 meters per second. Let's start writing these things down. And we have car B that's also going forward, but it's going slower at 15 meters per second. So it talks about A catching up to B, which it will eventually because A is going faster than B. So to start, it says that the position of A is 200 meters behind the position of B. And in terms of their position, A is 200 meters behind B. And so if they start moving, they're both going to move at the same amount of time. And if it's asking, how far is A going to travel in order to catch up with B? So catching up with B, in order to catch up with B, A, in order to catch up with car B, A goes the same distance that B goes, because B travels a certain distance, so A has to cover that. And then it also has to cover an additional 200 meters. So the distance that A goes is the distance that B goes, plus an additional 200 meters. All right, so basically this is going to boil down to a system of equations. We're going to have to solve for the amount of time that they went, and then using the time and the speed of A, we can figure out how far A went. But let's give this a go. So the fact that they travel for the same time is a good starting point. We're traveling constant speed, so the equation is V equals D over T. So yeah, v is d over t, so t is d over v. The reason why I'm writing it that way is because the times are the same. You can set the times equal to each other, so that means the distance of a over the speed of a is equal to the distance of b over the speed of b. Now we know that the distance of a is the distance of b plus 200. And now the only thing we need to do is solve for the distance of b, because we know the speeds of cars A and B. A is 20 meters per second and B is 15 meters per second. So yeah, collecting terms and solving for the distance of B, we get 600 meters. And then the distance of A is the distance of B plus 200, and we get 800 meters. So A has to travel 800 meters. There's another way of doing this problem. So I'm going to leave this here for a sec so you can look it over if you wish. But then I'm going to erase it and give another approach. So if we make like a table of values at time 0, and we say that A is at 0 meters and B is 200 meters ahead of A, and then let the clock run and see what happens. See at what point do the two distances equal each other, that they've gone, that where even with D, with B, the car B being 200 meters ahead, at what time, at what point do the distances equal each other? And it doesn't even say what time, just what distance is that. So let's run the table. So just like kind of making a bunch of times and then, seeing how far each car goes, at 40 seconds, both A and B are at the 800 meter mark, and that's where they cross each other. So it's at 800 meters that that occurs, and that's choice 3. I would say not an easy problem. Okay, we have 42. They give us the resistance and the time and the current, and they want to know how much charge passes by. So with the time and the current, I can do a pretty basic I equals Q over T to solve this problem, and I'm going to be solving for Q. So I put in the current, and that would be 2.4 times 10 to the negative 3 amps is Q over 15 seconds. Now be careful here. Notice that it says milliamps. So it's not just amps. And so milli, if we look at page 1 of the reference tables, milli is 10 to the negative 3. So that's 2.4 times 10 to the negative 3 amperes. Be careful there. And if we solve for Q here, we get I times T. 2.4 times 10 to the negative 3 times 15. We get 0.036 coulombs. So Q, we'll write that here. Q is 0.036 coulombs, which is choice 2 right over here. And then the last guy in this column, we have a 1,000 kilogram car going 20 meters per second east and experiences an impulse of 2,000 newton seconds west. What's the final velocity of the car after the impulse has been applied? So road time, I given information. I know the mass. I know the initial velocity. I put the impulse in as negative because the impulse is west when the initial velocity is east. So be careful there. It's going the other direction. And we want to know what V final is. And so the equation that I'm interested in is that impulse is equal to m delta v. Remember that portion, that's not on the reference tables. That portion of the equation, I think it's written out as J equals F net T equals change in momentum. And then there's the equals m delta v piece that's not on the reference table. Remembering that delta means final minus initial, I put in the impulse, that's negative 2,000 newton seconds. I put in the mass of 1,000 kilograms. V final is what I am looking for, and my V initial is 20 meters per second. All right, let's solve. And so when we solve for VF, we get 18 meters per second. And there's only one 18 meter per second choice. It comes out as positive, so we're still going east. And so we wind up with 43 being choice 1. All right, let's go after the next page. I want to get rid of this table. We used the table, now it's going to interfere with my next page. All right, there are 50 multiple choice, and so number 50 ends the B1 questions, but we're not up to 50, we're up to number 44. So let's go from there. All right, number 44, we have graphs of potential difference versus current. And so the relationship here is R is V over I, and then another way we can write this is that V equals IR. And if we write it that way, we see that voltage, or potential difference, which is also known as voltage, and current are directly proportional. Directly proportional. Proportional. And anything that is directly proportional looks like that graph. As voltage goes up, current goes up. So 44 is 1. Incidentally, the slope of that graph is equal to the resistance. They didn't ask that, but that's just like a good fact to know. Okay, let's move on to next question. Tungsten wire. And it says, tungsten wire resistance R at room temperature. Second tungsten wire, also at room temperature, has twice the length but half the area. So we have proportional change questions, twice and half the cross-sectional area of the first wire. In terms of R, what's the resistance of the second wire? So we're making proportional changes here. They're both made of tungsten, and so the resistivity is going to be the same. But we have twice as much length and half the cross-sectional area. And so we wind up with 2 divided by a half, which is the same as 2 times 2, which is 4 times the resistance. And so the second wire is going to have 4 times the resistance of the first wire, choice 4. Okay, 46 is talking about another resistance type situation. We have a lamp where the filament is getting hotter, and it says goes from room temperature to operating temperature. As the temperature of the filament goes up, what happens to resistance and current? So one thing we know about conductors is that as the temperature of the conductor goes up, the resistivity goes up. And if the resistivity goes up, the resistance also goes up, because resistance and resistivity are directly proportional. So the resistance is going to go up, so it's either 1 or 2. And then if resistance goes up, we also know that current goes down. That's one of the best examples of an inverse proportion. R and I are inversely proportional. That's why they call it proportional. But that's why they call it resistance. It resists current. So as resistance goes up, the current goes down. So that is choice 1. Okay, so for number 47, we're dealing with diffraction, which is how a wave wraps around a barrier when it hits the wave. And you get the greatest diffraction effect when the opening in the wall is less than or equal to the wavelength of the wave. And let's remember that the wavelength of the wave is from one wavefront to the other. So if I'm looking at, say, like these waves here, from one wave crest to the next wave crest, that is the wavelength there. So if I'm looking at these guys here, the wavelength is a little bit bigger. That's the wavelength of that guy. So I want to choose one where the gap size is smaller than or equal to the wavelength of the wave. And I would say of the 4 choices, choice 2, where the gap size is about the same as the wavelength. All of the other choices, 1, 3, and 4, the gap size is larger than the wavelength. So 47 would be choice 2. Then we have 48, we have a giveaway here term, natural frequency of the glass, shattering the glass by singing at it. If you hit an object at its natural frequency, it'll vibrate along with your wave, but then the amplitude of the vibrations will increase a lot, by a whole heck of a lot, because you're pretty much in phase with the vibration of the natural frequency of that object. But watch for natural frequency, and I don't even need SDP. SDP usually refers to the speed of sound at let's see. Oh, wait a minute. We do need STP because they give us the wavelength, they don't give us the frequency. Oh, that's interesting. So this is a resonance question because it refers to natural frequency, but really what it wants us to do is solve for the frequency given the wavelength. So the wavelength is 0.32 meters. The speed of the wave is the speed of sound at STP, which is 331 meters per second. That's from page 1 of the reference tables. And it wants to know what is the frequency equal to. So we're going to use V equals F lambda to solve for the frequency. That's 1034 hertz, or 1.03 times 10 to the 3 hertz. That would be choice 3. Original number is 3 significant figures for the wavelength, so our answer has 3 significant figures as well. And we have these last two questions in multiple choice. We have 49 and 50. Let's take a look at 49. So we have a picture of a standing wave. The wave's not traveling anywhere. And then on the standing wave, we have the nodes, the points of maximum destructive interference. Those are the red circles there. There's no motion at a node, and that's where max destructive interference happens at those points. And while that's real cute, the question says maximum constructive interference. Maximum constructive interference. That is not what happens at a node. That is what happens at the antinodes. And the antinodes are where you get the most motion back and forth. So we have 3 nodes and we have 2 antinodes. And so that would be the antinodes are occurring at at B and at D. So constructive interference does not happen at a node at all, so it's definitely not 2 and not 4. It happens at an antinode, and the antinodes in this case are at B and D, and so 49 is choice 3. And then number 50, I have some circuits. I have series circuits and parallel circuits, and it says the voltmeter V, how is it connected correctly in order to measure voltage across resistor R2. So I know that voltmeters are always connected in parallel across whatever they are measuring. So here we can find R2 in choice 1. Here's R2, but the voltmeter is holding hands in series, so it's not that guy. Voltmeter needs to be across it. Here again I have R2 with the voltmeter holding hands in series with it. It is not choice 4. Here I have R2, and look at that. I have a voltmeter going in for a hug. One probe on one side, one probe on the other. That is a parallel connection. And then choice 3 is our best choice here. And then choice 2 looks like the voltmeter is in parallel with R2, but that voltmeter is actually in parallel across both R1 and R2, and they just wanted R2 by itself, and so it is not choice 2, it's going to be choice 3. And that does it for our multiple choice. That doesn't do it for this video though, because I wanted this video to be all about part B. So we have B1 and we have B2. Where is, C is over here. So let's wrap up B2 and go from there. Now I don't have the answer booklet here, so I'm actually going to do the work on the test paper, but you would do the work in your answer booklet. Alright, so here it says directions 51 to 65. Record your answers in the spaces provided in your answer booklet. Some questions may require the use of the 2006 edition reference tables of physical set in physics. This class is loud. I'm going to shut the door. Base your answer to questions 51 through 53 on the info diagram below and your knowledge of physics. As represented in the diagram below, constant 50 Newton force F is applied to a 2.5 kilogram box. So let's start writing that down. I'll call that the pushing force of 15 newtons is on a mass of 2.5 kilograms, and it accelerates that box at 2 meters per second squared to the right. on a rough horizontal surface, so it's not frictionless. 51, 52. First of all, when they have, if there is a 2-point question, they will give it 2 question numbers. So whenever you see that, it's just like every question number is associated with a point. So the 2-point questions have 2 question numbers. So don't let that throw you off. Anyway, what is the net force acting on the box? So here, let's zoom in a little bit, give myself a little room. So I know that net force is A equals F net over M, and I know the acceleration, and I know the mass, so I can solve for the net force. And I wind up with a net force of 5 newtons when I cross multiply. Then 53 wants to know what is the force of friction on the box. So the first thing that I'm going to try is FF is mu Fn, but I do not know mu. I have no blessed idea what mu is, so I'm not going to use that equation. My backup equation for friction is that net is push minus friction, right? That is not on the ref tabs. Not on ref tabs. But I know my net force is 5 newtons. I know the pushing force is 15 newtons, and so the friction force is the difference. That friction force is 10 newtons. Now that's a 1-point question, so you don't actually need to show the work. You can just put the answer down. Okay, 54, 55, we have ourselves a refraction situation. So I have a ray of light. Here's the frequency, the reference frequency here. 5.09 times 10 to the 14 hertz is going through a mineral sample submerged in water. We don't know what the mineral is. Ray refracts as it enters the water as shown in the diagram below. Well, first of all, I can tell just by looking at this that the ray is bending away from the normal. So big, we have blob, big index, big N to little n, and the ray bends away from the normal. And so I can see that the ray is in fact bending away, so that the angle of refraction is bigger than the incidence angle. So then the water, N of water, the index of water is less than whatever the index of the material is. So it says calculate the absolute index of refraction. It should be greater than 1.33. I don't actually need that here to solve the problem. All I need is Snell's law, but just for what it's worth, I know what I'm looking for. So I have n1 sine theta 1 equals n2 sine theta 2. I know my angles, I know my n2, I'm solving for n1. Be in degree mode for this. Now, be careful. They gave us 4 angles here. We measure from the normal, we do not measure from the boundary. So this is theta 1 right here, and this is theta 2 right there. Okay, don't forget the degree symbol for your units. That matters. That counts as units. If you leave that out, you're going to lose the unit point. Now, in terms of, and the 1.33, how did I know that the water, the index, is 1.33? That is on page 2 of your reference tables, ref tabs, for water. So that's where I got that one from. Now, so basically I'm solving for N1 now. And I got an index of refraction, which is 1.92. And there are no units for N. The units are not hertz. So there's 54, 55. All right. Okay, let's move on to the next question. Base your answers to questions 56 through 58 on the info below in your knowledge of physics. Balls are rolled twice across the same level lab table and allowed to roll off the table and strike the floor. In each trial, the time it takes the ball to travel from the edge to the table to the floor is accurately measured. We did this lab. This was the horizontal projectile lab. Neglect friction. 56, 57. Trial A, the ball is going 2.5 meters per second when it reaches the edge of the table. The ball strikes the floor 0.391 seconds after rolling against the edge of the table. What is the height of the table? This is a horizontal projectile question. It's horizontal projectile. And so we will set up a table in order to deal with that. Then 58 is comparing time. Let's revisit that question. But I'm going to make a table. Where am I going to put my table? I think I'm going to cheat and zoom in. So making a table for a horizontal projectile. Alright, so I know the accelerations always of any projectile. And then the stuff it told me 2.5 meters per second rolling horizontally. So I know that initial x velocity is 2.5 meters per second, and it's rolling horizontally off of the table, so the initial y velocity is 0 because it's a horizontal projectile. Again, if I were to draw like a picture of this, we have a ball rolling off of the table completely horizontally at 2.5 meters per second, and it falls down to the ground. And the time it takes to do that is 0.391 seconds. So the time in the air is 0.391 seconds. All right, fine. And it says, what is the height of the table? So that would be this guy right here. So to solve for the height of the table, let's see, where can I do that? I'm going to do it over here. I can say d is VIT plus 1/2 AT squared with the y information, because the height of the table is a y displacement. So y displacement is initial y velocity times the time plus 1/2 times the y acceleration times the time squared. There is no initial y velocity. It's a horizontal projectile. So I just have 1/2 negative 9.81 meters per second squared times the time in the air squared. Don't forget to square it. Most common careless mistake is forgetting to square or square root. And 0.391 squared. Make sure I entered that correctly. And that's 0.75 meters. And that makes sense. About 3/4 of a meter off the ground. And so that is the height of the table, 0.75 meters. It says include equation and substitution with units, so you would need to show all of that work. You don't have to show the table, but you do have to show the equation, unit substitution, and answer with units. Okay, then 58. Ball is going 5 meters per second when it reaches the edge of the table. Compare the time it took for the... Oh, in trial B, it's going twice as fast. Compare the time it took. Time it took as compared to the first one. Time is going to be the same. Same time in air. Now it says compare. It doesn't say explain, so you don't actually have to explain it. But I'll explain it. So if we have a ball rolling off of the table and it rolls faster, instead of going 2.5 meters per second, it goes 5 meters per second, that doesn't change the vertical information. And the time in the air, there's no change in the vertical information. If it goes faster off the table, it will go farther. It will get a greater range. The x displacement will be higher. It'll go farther away from the edge of the table on the floor. But that time in the air is going to be the same because the time depends on the vertical information and there would be no change in the vertical information. So that's 58. Now we have 59 through 61. So 59 through 61, circular motion problem. Toy airplane flies clockwise, so it's going, oops, wrong tool. Here, clockwise. At constant speed, a horizontal circle of radius 8 meters. Acceleration is 25 meters per second squared, and the diagram shows the plane as it travels around the circle. 59 to 60, what is the speed of the airplane? So things that I know. I know my acceleration and my radius. I need the speed. Speed is 14 meters per second. Don't forget to square root. All right, what is the direction of the velocity when the acceleration is south? Well, let's remember that the acceleration is always pointing inwards. So the acceleration is always inwards for the plane, and then looking at the compass, south would be the top position. And so the velocity, when the acceleration is south, the velocity is straight forwards east. And it's important that we know that the plane is clockwise, otherwise the answer would have been west. So two more question sets. We have 62 through 64. We have a speed versus time graph. I know right off the bat that the slope equals acceleration, and that the area under the curve is displacement. All right, so he says, speed of a marble rolling down a straight incline is a function of time. Speed versus time for a marble. 62. What's represented by the slope? Well, we just said that. Slope is acceleration. The reason why that's true is that we know that slope is delta y over delta x, but the y-axis in this case is velocity. So it would be change in velocity over change in time. That's the definition of acceleration. So that's why slope is acceleration. And then 63, 64, what's the distance the marble travels in the first 3 seconds? Distance is the area under the curve, but only during the first 3 seconds. So I'm interested in this triangle right here. I can do 1/2 base times height. That would work. I can do v equals d over t, but I would need the average speed of 2 meters per second, not 4 meters per second, because the speed is changing. But using this area equation, base is 3 seconds, height is 4 meters per second. See that, 4 meters per second. And so half of that is 6 meters. Now this says show all work, so you're gonna have to give some kind of equation and unit substitution for this problem. All right, and then the last thing in B2, because then we start C. B2 is 65, and we have weight versus mass. I know that the slope of this guy is acceleration due to gravity. Slope is rise over run, delta y over delta x. That would be weight over mass. I know that acceleration due to gravity is weight over mass, and so that is going to be the slope of this line. And so if it says determine acceleration due to gravity, g, of the surface of planet X, that would be the slope. So if we take a 2-point slope, let's see, these guys look good. We have 2 kilograms, 6 newtons, and up here we have 6 kilograms and 18 newtons. We got 18 newtons minus 6 newtons over 6 kilograms minus 2 kilograms slope is 12 over 4, which is 3 meters per second squared. 3, not 30. Now, this is a 1-point question, so you only needed to give an answer. And that is B2 and the end of this video. Next one will be for part C.